All right, today's first video, we're going to talk about absolute value functions. This is the most basic looking absolute value function that I can show you. Obviously, absolute value means you're talking about the distance away from 0. So when you put in a number like 1, it is what just happened. 1, it is 1 unit away from 0. And negative 1 is also 1 unit away from 0. So you end up getting a shape that looks like this. The vertex is at the point 0, 0. Vertex meaning the point where it changes direction. And then also we have slopes of the lines, which are positive 1 and negative 1. This does open up. Now let's take a look at the more generic form of the equation. The equation that we need to focus on in a generic sense looks like this one right here. Y equals A times the absolute value of mx plus b plus c. Now hopefully you see right inside here that there is a line. But when we take the absolute value, it takes all of the negative y values and makes them positive. That's kind of the basic thought behind it. Now, we could start moving these things around, and when we start moving them around, that's when we get all kinds of things in different places. Now, how do I look at that and tell basic information? Well, the a value, that controls whether it opens up or opens down. Obviously, if it's a number larger than 0, a positive number, it is going to open up, just like the one you saw a few seconds ago. And if it's a negative number, it opens down. So you need to know that the multiplier in front of the absolute value bars is controlling whether it faces up or faces down. Anyway, so how do I find the vertex? It's actually pretty easy. We do the opposite of b over m. That's your x value of your vertex. So you actually have to know what m and b are, and you'll have to use them in that little shortcut formula for x. And then over here, you have the vertical shift up or down, C. Okay, opposite of b over m, comma, C. Now, that opposite of b over m could also be used for the axis of symmetry, and I didn't write that down, but if you hear or come across that term, axis of symmetry, that would be another time where you would use that. Well, that's a bad looking M. Whew, not getting much better. X equals, and then you would do the opposite of b over m. That's a vertical line which cuts this thing in half. Okay, they do match because the axis of symmetry always goes through the vertex. So this will be what we use to find the vertex of a particular absolute value function. That opposite of b over m is the part that controls whether it's shifting left or shifting right. Okay. Based on whether it's a positive or a negative number. Now, you might say, well, it looks like it's always going to be negative. Yeah, but what if b is a negative number? Or what if m is a negative number? That could cause that negative to turn positive pretty quickly. So that's why I say that whole fraction decides whether it moves left or right. C is pretty common sense. That's up or down. That's your shifting up or down. Are you sliding it up, sliding it down, that kind of thing. It's very common sense. It's not like it when you see the vertex, it's in the formula. So anyway, let's get to our first example because they take a little bit of time. Where's my controls so I can pause this thing? Oh my goodness, I feel stupid. There it is. All right, so in this example, we have to, what I suggest you do, every time you have a new problem, you want to look at it and you want to find A, M, B, and C. That's the first thing I want you to do. And you can see over here on the side, I wrote down A, that's the first number, that's the coefficient on the outside. I wrote that down, that's negative 4. M, M is the number that's being multiplied times the x right there, and that is a 1. It's a positive 1. You'll notice that nothing is being added to the x. That's the b part, so that must be 0 because that's addition. Multiplication, we don't see anything that's a 1, but when you're adding it, you don't see anything that's a 0. Okay, and once again, on the outside, I don't see anything out there, so that must also be a 0. So if I go through the process of, let's see here, clear this off, and shrink this. That's not what I wanted. I hate it when I don't do that right. If I want to go through the process of the opposite of b over m, right? Remember that? Opposite of b over m. comma, C for the vertex, right? That would be the opposite of 0. Well, we know the opposite of 0 is still 0, okay? And then we've got the m value, which is a 1. Well, anytime you take 0 and divide by anything, you still get 0. And then, of course, the C value is 0 itself. So 0, 0 is where this thing's starting from. We can tell because this is negative that it opens down, all right? So we already know it's opening down. It has a vertex of 0, 0. The slopes are, and you can see that I circled these two, right? Because we know that it's the product of A times M, and that's what we have right there. Don't worry about whether the product is positive 4 or negative 4, because you have to have one slope that's positive and one's negative, so you're automatically going to get a positive and a negative no matter what that product ends up being. Okay, let me pause this so I can see which choice this is. No. As you can see from this picture, we're at the vertex is 0, 0. It's opening down. The slopes, you can tell that if you go down 4 and 1 over, you have one of the slopes. That's a negative 4 slope. And if you go down 4 and back to the left, that's a positive 4 slope. So you can tell this is the one you wanted. Let me pause for moving to the next. So what kind of words can you use to describe what's happened? Okay. The parent function, you know, that's the original one, the y equals x with slopes of 1 and negative 1 that started at the origin. Let's see here. It got reflected across, not the y-axis, it got reflected across the x-axis. So we definitely have to have something about reflection across the x-axis. So it can't be choice B. It did get vertically stretched, okay? The reason I know it's stretched is because you're pulling the points down. Compressed would be like this graph over here or this graph over here where you're shrinking the y values. This one got vertically stretched and reflected across, so this is choice A. I'm going to apologize for making this a longer video. I thought I could make it shorter than it's going to be. Alright, so we're just going to run through a few of these as fast as we possibly can. We've got an A value of negative 2/3. Inside here we have a B value, or an M value of 1, a B value of 0, and a C value of 0, right? Just kind of like the last one. So if we go opposite of B over M, comma, C, we're going to get that 0, 0 starting point. We can tell that it opens down. We can tell, what did I write that in the slopes category for? Please excuse my stupidity. Apologize. Yeah, so you got the idea. The vertex is 0, 0, not the slopes. Gee whiz, I think you guys think I was crazy. Plus or minus A times M would make that 2/3. So because this is a fraction, we're going to be shrinking the y values. I think this particular Math Excel likes to use the word compressed, but it's the idea of shrinking. Okay, so let me jump down to the picture. So this one has a vertex at 0, and if you come down 2 and over 3, and down 2 and back 3, you can tell that it is choice A. You can tell that the points have been, they haven't not been stretched, they've actually been brought closer to, you know, the normal y equals x is, or negative x would be going like that. If it had a negative absolute value of x, it would be going upside down like that. Sorry, my camera keeps moving. Okay, next question. So which statement are we looking at? We want something that's been compressed vertically. Yep, definitely. Reflected in the x-axis. Wow, that looks like the one right there. Yep, that's the one. Okay, next question. Okay, so now we can see that the A value is positive 1 this time. M is positive 1. This time, the B value, remember the B value inside there is negative 6. And the C value on the outside is negative 5. So if we go with that opposite of B over M, comma, C, we can tell that our vertex is the coordinate 6, negative 5. So you get that in your mind. That's really right 6. So we're moving this thing right 6 and down 5. Okay, this is different from what we did before with. Now the axis of symmetry, remember I've talked about that before, that goes with, now you'll see that they've already got the x equals part right here, so I don't have to do that. This is going to come right here, 6. Because remember, the first part of the vertex is the value that you use, because that that vertical line is going to go right through the point that we call the vertex when we get to the graphing part. Okay, let me look at the graph. I guess this one doesn't have us graph it. So function is translated 5 units down. That's true. And vertically stretched. Ooh, I don't think there was any vertical stretch going on. Nope. So anything that mentions vertical stretch is out. We wanted to go 6 to the right and 5 down. There it is. Letter E. 6 to the right and 5 down. So this graph just got moved. 6 to the right, 5 down. So visually speaking, you'd be looking at a vertex over here with slopes of 1 and -1. All that, if we were to graph it out. In this particular equation, we're looking at the actual graph, and we're going backwards, and we're trying to figure out what the equation would be. So when we look at this, we can see that, well, right now we know what the vertex is, right? 4, -3. Okay, so that's information we can use. We also know the slopes are plus and minus 1/5 up 1/5. And we know that the A value is positive because the whole thing opens up. So I'm going to kind of write my answer down here. So something times something, we got something times x. And then so here's what we're going to do here. We're going to go through the process of figuring out what we have. I'm going to put 1/5 out here. And I'm going to put 1 in here. Then I have a -4. Is that right? Yep. And then a -3. Okay. And you might be wondering to yourself, well, wait a sec. That looks like a +4. But remember, it's opposite of B over M. So you have to think a little bit backwards in that particular sense. So it's probably better if we looked at it like this. 1/5 absolute value, x minus 4. That's probably a better way to look at the whole graph. Okay? And that would be the answer to the question. Sorry for such a long video, but there's just so many pieces inside here, and I just wanted to... So the first thing I do when I look at the whole thing is I go down my list, and I find my A, my M, my B, and my C. Right, -2, +1, -3, and +4. We know that it's opening down, right, because that's a negative value in front. We know that we're sliding it over 3 to the right. When kids look at this and they see that -3 inside there, they think it's going left, but it always goes against, and that's because of that whole opposite of B over M thing going on here. That little opposite thing throws people off. They don't realize that it actually is moving to the right. The part on the outside matches their common sense, so that doesn't bother them. So we know that this is going 3 to the right and 4 up. Okay? We know that it's opening down. We also know the slopes of the lines are plus and minus A times M, right? So 2. Plus and minus 2. So that's what we're going to have to use to graph this. Well, see, D and A are the only ones... or I should say A and D, it doesn't really matter. They're the only ones that open down, so I know I can get rid of those two choices. And then it looks like this one got shrunk. D got shrunk, so I don't think that's the right one. I believe you're looking at letter choice A, which makes more sense because if you, and you know what, I would need to zoom in for a better looking picture on this. But you can tell that if you go down 2 and over 1, or down 2 and back 1, you actually hit the lines. So it does have the correct slopes, this one being -2 and this one being +2. So that's good news. We know which choice it is. So list the x-intercepts and the y-intercepts. Well, so there's a little bit of algebra here. The y-intercepts are actually pretty easy, right? You just want x values to be 0. So we can easily plug in an x value of 0, right? -2 times 0 minus 3 plus 4. Okay, so we can figure out that inside there is -3, but when you take the absolute value, it becomes +3. So we have -2 times 3 plus 4, which is -6 plus 4, which makes that -2. So the y-intercept is -2. Now, it does say type an ordered pair. So I guess we would need to back up and we would need to write the coordinate 0 for x, -2 for y. Okay, now that's the easy part. The other part is a little more complicated. Not too bad, actually, because you've already done this kind of thing. So on the x-intercepts part, we want a y value of 0. So you'll notice I put a y value of 0 in, and then we want to start solving. Well, this is no different than what you guys did before, where you isolate the absolute value bars, right? The 4 comes over to the other side, making it -4, and then you divide out -2. So it basically gets us to this point right here, where the absolute value bars are isolated, and then it's time to split it into its two equations. One that looks like the original without the absolute value bars, and one that looks like it with the exception that you switch to the other side. If you add the 3 to that side, we now know that 5 is one of your x-intercepts. So I didn't leave myself enough room here. 5, 0 would be one of the answers. And adding 3 to the other side would make that x equals 1. And so we would have comma 1, 0. Okay? It does say use a comma to separate your answers as needed. And there are 2 in this particular situation. Now, did I have to do all of that work if I could look up here at the picture and identify them? I'm guessing not. You know, as a math teacher, I want you to be able to do that. But if you've already got the picture in the graph, probably just use the graph, in my opinion. Anyway, sorry for the length of this video. Did not mean it to go this long, but there was a lot of information, more information than I even imagined. Hopefully the other ones are shorter.